Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good morning to everyone. Today I would like to share with you guys on how to perform the analysis of the basic diode circuit. Alright, okay, we move to the first question. Okay, analyze the biasing condition of each diode in figure Q1D, hence determine the value of I1, I2 and V0. Okay, basically we have three steps to perform the analysis of the basic diode circuit. Alright, the first one, okay, so this one you must remember. Okay, the first one is identify the condition of the diode. Okay, the condition of the diodes. Okay, either on state or off state. Or on state, other words we call as a forward bias, and the off state, the other word we call as a reverse bias. Right. So number two, okay, redraw the circuit. Alright, so redraw the basic diode circuit. Okay, why we need to redraw the circuit? Okay, because to make your analysis of the diode more easier, so we need to redraw the circuit to in the form dalam bentuk yang senang untuk you buat analisis. Right. Okay, the third one, okay, you need to apply, okay, you need to apply Kirchhoff voltage law as well as a Kirchhoff current law to perform the diode analysis. Alright, okay, we move to the first one, identify the condition of the diode. So as mentioned before, we have two state. Okay, either on state or off state. Right. So kalau you tengok kat sini, okay, on state, your diode should be, the symbol of the diode should be like this. Okay, dia punya arrow must be facing from left to right. Alright. Okay, then the other one is off state. Your arrow, the diode symbol or arrow, okay, facing backward like this. Right, this one is off state. So kalau tengok kat sini, okay, we have 4 diode. Right. Okay, we need to analyze one by one lah. Right. The first one, okay, GE diode is, okay, diode number 1, first one. Okay, this one is a forward bias. Okay, because the arrow facing to the right. Okay, so yang ni adalah on state. Okay, number 1, diode 1, okay, kita letak sini D1 lah. Right, D1. Okay, D1 is on state. Alright, okay, followed by D2, also on state. Okay, the third one, this one, the silicon diode. Okay, the one number 3, also on state. Okay, the last one, ideal diode. This one, okay, they're facing upward. Alright, this one we call as a reverse lah. Okay, reverse condition. So diode 4, diode 4 is off state. Alright, okay. Okay, so we already done for the step number 1. Okay, to identify the condition of the diode. Right, then the second step number 1. Okay, step number 2, you need to redraw the circuit. Right, supaya memudahkan you untuk buat analisis. Alright, so okay, as mentioned in the class, right, so for the forward bias condition, we need to replace with short circuit or power supply. Okay, if let's say your diode. For example, here we have a silicon diode, okay, germanium diode and ideal diode. So normally ada tiga ni lah yang biasanya kita pakai. So silicon diode, the voltage is around 0.7 volt, germanium diode is 0.3 volt, and ideal diode is 0 volt. Right, so normally silicon and germanium, since they have a voltage here, so we can draw just represent as a power supply symbol like this. Alright, okay, satu panjang satu pendek, positive and negative, right, like this. Alright, for the ideal diode, you can draw like a short circuit, right? Okay, this one when your diode in on state, okay, in on state or forward bias. Alright, okay, now we move to off state. Okay, when your diode in the off state or reverse bias. Alright, so all the diode symbol you can replace with the open circuit. Alright, like this. Okay, right, then after that you can redraw the circuit. Right, we starting from power supply 12 volt. Right, you must redraw like this, okay, untuk memudahkan you buat analisis. Right, and follow, okay, you put the symbol positive and negative 12 volt. Right, followed by the resistor. Right, and next is your diode. Okay, basically for your diode, as you can see here, your diode connected in parallel. Okay, dia bersambung secara selari. Alright, so the voltage between diode 1 and diode 2 is same. Okay, this one germanium is 0.3 volt, and here also 0.3 volt. So we for the parallel we only consider only one diode. Okay, satu lagi tu because dia ada parallel, you letak 3 ke 4 ke, dia punya voltage adalah sama. Alright, so here we just represent as a one diode. So I put here only one diode. Alright, okay, then followed by the V out here, then your silicon diode. Okay, you can draw as a power supply symbol. Right, and then your ideal diode is, since your ideal diode in the off state, which is the reverse bias condition, so your diode should be your circuit should be open. Right, and then next is your resistor, followed by the DC voltage here, negative, positive, 5 volt. Okay, lastly you can put a ground here. Right, okay, kalau you tak nak lukis, since your ideal diode is open circuit, if let's say you don't want to draw the ideal diode, okay, you can remove it. Okay, you can remove it. Okay, you can draw like this. Alright, this one plus minus 0.7 volt, and here plus minus is your V out lah. Right, okay, okay, now you can put the symbol. Here is 2.2 kilo ohm, right, and then here is 4.7 kilo ohm. Okay, for the germanium diode is 0.3 volt, and for the silicon diode is 0.7 volt. Right, okay, the direction of I1, okay, this one I1, your I2, okay, tadi adalah, okay, because since I2 is parallel, right, so I2 is here. Alright, okay, alright, okay, now already done for the step number 2. Okay, sekarang kita move. Now we move to step number 3. Okay, which is we need to perform the analysis of the diode using KVL or KCL. Okay, KVL state that all the voltage in the loop or in the circuit, this one is must be equal to 0. Right? So the total voltage in the loop must be equal to 0 volt. Right? This one is a KVL rules. Right? Rules for the KVL. Alright. So here I make a loop here, clockwise loop. Alright. Okay, so I'm starting from power supply. Okay, followed by resistor. Alright, and diode, germanium diode, silicon diode, 4.7 kilo ohm resistor, and the DC supply 5 volt. Alright, so every single component they have their own voltage drop. Alright, so kita kena minus lah 12 starting from the high potential from your power supply 12 volt, right? So you need to minus the voltage drop here, the diode, silicon diode here and here. Then you will get the then you can equal to 0 lah. Alright, so okay, we start from the power supply. Okay, the polarity is negative, right? So you starting from the negative 12 volt. Okay, followed by this resistor, the voltage drop according to the Ohm law, V equal to IR. So here the voltage drop for this resistor is equal to I1 times 2.2 kilo ohm, right? Or simply we call it as here V1 lah, right? Okay, followed by plus by germanium diode. Okay, germanium diode is equal to 0.3 volt, and then okay, followed by the silicon diode plus 0.7 volt. Alright, and then again here we have a voltage drop for this resistor 4.7 kilo ohm. Okay, we just simply put I1 times 4.7 kilo ohm, or simply call it as a V2 here, and then the last one is a minus. You can see the polarity, right? Kalau jumpa negative dulu, then here you must put the negative. So minus, okay, 5 volt. Alright, or you can write like this. Okay, plus, okay, you can put plus negative 5 volt equal to 0. Right? And then okay, you solve, you rearrange this equation, okay, to become like this lah. I1 equal I1 times 2.2 K plus 4.7 K. Okay, yang mana ada variable ataupun boleh ubah dengan yang tak ada lah. Okay, here I put the equation which consists of the I1 I put at the left side. Okay, then yang tak ada pun boleh ubah tu I just put in the right side. So 12 minus 0.3 minus 0.7, okay, plus 5, right? So you will get here I1 equal to, okay, 12 minus 0.3 minus 0.7 plus 5. So here you will get 16 divided by 2.2 times plus 4.7. So you will get here 6.9. Okay, 6.9K. Right. So you solve this this equation, you will get 6.9K. So you will get here the current I1 is equal to 2.32 milliampere. Right. Okay. So now okay, we need to find the value for the I2. So I2, as you can see in the question, okay, figure Q1D, okay, I2 ni, okay, ia dekat dekat circuit yang parallel ni, germanium circuit, alright. So which is connected in parallel. So this one is a I1, alright, and then this one is a I2 lah, alright. Here also I2, right. Since dia ada two branch, okay, so we just simply, okay, the current you just simply I1 you just simply divide by 2 lah, okay, because dia terpecah dua, dia split by 2, right. So you can solve like this. I2 equal to I1 divide by 2, because dia punya component is same, okay, germanium and germanium, okay, sama. Kalau let's say germanium and silicon, because dia punya voltage different, so dia punya current also will be different, right. So I1 divided by 2, so I1 is just now 2.32 milliampere, okay, divide by 2, then here you will get 1.16 milliampere, right. So now, okay, we already settle I1 and I2, right. And the last one, okay, we need to settle on the V0. Okay, V0. Okay, I write at here, right. So V0. Okay, kita cari V0 from, okay, from this area, alright. So we know that V0 is V0 is parallel with this circuit, alright. So you can write like this: V0 equal to 0.7, which is a silicon diode voltage, alright, plus I1 times 4.7K minus 5 volt, right. So okay, you replace the I1, okay, with 2.32 milli times 4.7K, right. So here you will get 6.6 volt, alright. Okay, so okay, you can use the KVL, okay, KVL at the output side. So for example kat sini I make the loop here, alright. So this one I make anti-clockwise, okay. Okay, I starting from this one V0, okay, dia akan jumpa negatif dulu lah. So negative V0, okay, then follow by dia akan jumpa silicon diode, okay, plus 0.7. Next is this one, the voltage drop at the resistor, okay, I1 times 4.7K, and then the last one DC voltage minus, okay, dia berjumpa dengan negatif dulu kan, so minus 5 equal to 0. Okay, this one you apply the KVL. Okay, so you will get here V0 equal to 0.7 plus, okay, I want 2.32 times 4.7, so here you get 10.9 minus 5, so you will get, okay, the same value lah, 6.6 volt, alright. Okay, so another way to find the way out, you can find from this power supply, right. Okay, we know that this power supply is supplied 12 volt, right. Okay, we know dekat sini, alright. Okay, if you want to use this method, okay, you need to consider 12 volt, okay, voltage drop dekat sini, banyak dia punya voltage drop kat sini, so 12 volt must minus this voltage drop, okay. Just now we consider as a V1, 12 volt must minus V1 and then minus germanium diode, then you will get the V out, right? So V out equal to 12 we minus with the V1 is I1 times 2.2k, and then last one we need to minus with the 0.3. So here you will get 12 minus 2.32 times 2.2 minus 0.3. So you will get also 6.6 volt. Alright, so you can use either one method here. Alright, okay, that's it for the first tutorial. Okay, we move to the next tutorial. I hope you guys are able to understand what I delivered today. Alright, so we move to the second question. Alright, the series parallel diode configuration circuit shown in figure Q2A has the diode voltage for silicon, germanium and ideal diode are VSI equal to 0.7 volt, VGE equal to 0.3 volt and V ideal equal to 0 volt respectively. Identify the biasing condition of all diodes. Okay, the second one, compute I1 and V0. Okay, kita cari the first one, we need to identify the biasing condition. Alright, this one step number 1 lah. Alright, step number 1. Okay, kita kena identify the condition of the diode. Alright, as you can see, we have 4 diode here, and then the diode, okay, they are facing all the diode facing from left to right. So this one indicate that all the diode is are on conditions, right, of forward bias. So diode 1, okay, this one is silicon diode. Si is a on state ataupun forward bias, right, or on. Okay, the second one is germanium 1, also on. The third one, germanium 2, on, and last one, the ideal diode. The ideal also forward bias on state. Alright. Okay, then we move to the step number 2. Okay, we need to redraw the circuit. Alright, as you can see, okay, in this diode we have the parallel circuit here. We have 3 diode here. Okay, kita kena pilih satu sahaja diode. We choose only one diode. Okay, so here in this case, okay, you consider the lowest voltage value kat sini. Alright, for example, germanium 1, germanium 2 is same, which is 0.3 volt. Okay, and then the diode, the ideal diode is equal to 0 volt. So yang mana satu kita nak ambil? Right, kita ambil the lowest voltage value, which is ideal diode. Okay, 0 volt. Sebab apa? Okay, kalau the current flow, right? So which diode activated first? Alright. Okay, kalau tengok kat sini, yang mana yang operate first? Okay, yang berfungsi dulu. Okay, so of course lah ideal diode, because 0 volt. Okay, the current masuk kat sini, then ideal diode first yang akan activate. Alright, compare to germanium 1 and germanium 2, because they require 0.3 volt untuk activate both diode. Alright, so here in this case we only consider the lowest voltage value among 3 diode ni. Alright, so the lowest one is the ideal diode. Okay, so kita ambil ideal diode. Right, so as mentioned before, for the forward bias ataupun on state, kita akan represent as a either short circuit for the ideal diode and the power supply symbol for the silicon or germanium diode. Right, so we need to this one germanium 1 and germanium 2 we do not consider in this circuit analysis, okay, because dia punya voltage tinggi, much higher compared to the ideal diode. Okay, so kita akan remove germanium diode. Alright, so okay, starting from the power supply, you can draw like this. Okay, followed by the silicon diode, you can draw like a power supply symbol. Alright, and then followed by the ideal diode, short circuit, followed by 1.5 kilo ohm. The last one is the ground here. Here is plus minus V out, and here is 1.5 kilo ohm, here 3.3 kilo ohm, here plus minus silicon diode is 0.7 volt. Alright, the current I1 flow like this, and here is plus minus 20 volt. Alright, now we already draw the circuit, so daripada circuit ni mudah untuk kita buat analisis. Right, now we move to the step number 3, which is we need to apply KVL. KVL ni sangat-sangat penting in circuit analysis, in diode application, in BJT transistor analysis, DC analysis, AC analysis, FET pun sama, op-amp pun sama. So you guys need to know how to use the KVL correctly, right? Because banyak, dia punya application terlalu banyak, so nak tak nak you need to master in the KVL and KCL. Alright, so now we perform the analysis for the diode using KVL, Kirchhoff voltage law. Right, so saya buat loop kat sini, clockwise loop. Loop ni ikut arah jam, starting from the power supply. So the first one dia akan jumpa negative 20 volt, followed by positive 0.7 volt, then followed by I1 3.3 kilo. Then here is a 0 volt for the ideal diode, plus 0 volt. Then the last one here, I1 times 1.5 kilo, then must equal to 0 volt. Tak ada lagi kan dia punya komponen kat sini, so the last one you can put equal to 0 volt. Alright, so now you can solve the equation. I1 3.3k plus 1.5k, then 20 minus 0.7, right, minus 0, right, then I1 equal to 20 minus 0.7 is 19.3, right, 19.3. Then divide by this resistor value 4.8k. Alright, so you will get here 4.02 milliampere for the I1. Alright, so I1 done. The second one you need to find the value for V out. V out, as you can see here, V out is parallel with this one, right? So the voltage kat sini sama dengan voltage kat sini. Alright, for example I put here V2, here is a V1, right? So V0 is equal to V2 equal to I1 times R2. Alright, so I1 is now is 4.02 milli times with the R2 is 1.5 kilo ohm. So here you will get 6.03 volt. Alright, okay, or you can use the second method. Okay, you can apply the KVL. Okay, KVL, okay, make a loop here. Alright, okay, you can apply, okay, negative V out, okay, plus I1 times 1.5k equal to 0. Right, so V naught equal to I1 times 1.5k. Okay, you can apply again the same value lah. Okay, 6.03 volt. Alright, or the other method, okay, you can use starting from here lah. Okay, V naught here, V naught equal to 20, okay, 20 volt minus voltage drop at here for the silicon diode, okay, 0.7 volt minus the voltage drop at the resistor 3.3 kilo ohm, so minus I1 times 3.3 kilo ohm. So here you will get 20 minus 0.7 minus I1 is 4.02 times 3.3, so you get here 13.27. Right, so 20 minus 7, so here you get 6.03 volt. Okay, semua sama lah. Alright, okay, so this is a method to solve the output voltage. Alright, I think that's it for the second question. Okay, we move to the next question, okay, the last question. Question 3. Okay, for the question 3, okay, compute the current I1, I2, I3 and I4 for the diode circuit shown in figure Q2b. Assume that Vt for the silicon and germanium are 0.7 volt and 0.3 volt respectively. Alright, so this one is a figure Q2b. Okay, so as you can see here we have 4 current, I1, I2, I3 and I4. Right, so you must solve this, you must perform the analysis or the diode analysis to get the value for each current. Right, so we start from the I1 here. Okay, I1, okay, I1 is equal to, okay, here, right, so I1, okay, put here, okay, here is a plus minus V1, right, so V1 basically is same with the voltage, since this circuit is parallel, right, the voltage for the V1 and the voltage for germanium basically is same. Because sebab apa? Sebab dia adalah parallel, right? So we can write as V1 equal to VGE equal to, as mentioned, germanium diode is 0.3 volt, so 0.3 volt. Right, so V1 is equal to I1 R1. Alright, so I1 equal to V1 over R1 equal to, okay, V1 just now is 0.3 volt divided by R1. R1 is 100 ohm. Right, so here you will get 3 milliampere. Right, okay, so now, okay, you can find the second one. You can find the value for the I3. So I3 from this node, okay, as you can see, okay, you nampak sini, okay, I2, then here is the I1 lah, okay, I1. Right, so here you need to apply the KCL, okay, Kirchhoff current law. Right, okay, Kirchhoff current law dia mention apa? So dia mention current yang masuk sama dengan current yang keluar. Right, so okay, at this node, okay, I3 is a current yang keluar, okay, move out. Current yang move in is I1 and I2. So I3 is equal to I1 plus I2. Okay, current yang masuk I2 and I1 equal to current yang keluar, which is I3. Alright, so I3 equal to I1 plus I2. Alright, so next, okay, we need to get the value for the I3. So for this I3, you need to consider, you need to apply the KVL, right? Okay, this one. Okay, before you want to do a KVL, okay, you need to redraw the circuit. Alright. Okay, all the diode is in for bias condition, on condition, right? So you can redraw like this, plus minus 12 volt. And then diode, since as I mentioned to you before, if your circuit is parallel here, right, so you need to consider only one diode. Okay, for this case, since both diode are the same material, which is silicon, so the value here is 0.7 volt. So here, okay, plus minus 0.7 volt, right? Followed by germanium, right, plus minus 0.3 volt. Right here is 2.2 kilo ohm. Okay, here is 100 ohm. Alright, okay, so right, I3 kat sini. Okay, this one is I3. So you need to apply the KVL at this circuit. Okay, apply KVL. Right, okay, saya ambil loop ni lah. Okay, loop ni. Alright, starting from the power supply. Okay, negative 12. Okay, followed by plus 0.7 volt. Right, then dia akan jumpa plus 0.3 volt, the diode voltage for the germanium. Lastly akan jumpa dengan voltage drop at the 2.2 kilo ohm resistor, okay, which is plus I3 times 2.2 kilo, right, equal to 0. Right, then okay, we can solve it. So I3 equal to 12 minus 0.7 minus 0.3 divided by 2.2 kilo ohm. So here you will get, okay, 11 over 2.2 kilo ohm. So here you will get I3 equal to 5 milliampere. Alright, okay, so once you get the value for the I3, now you from this equation you can obtain the value for the I2. So I2 equal to I3 minus I1. Alright, so I3 just now is 5 milliampere minus I1 is 3 milliampere. So you will get the I2 equal to 2 milliampere. Right, okay, so the last one is I4. Okay, I4. So as I mentioned in the previous tutorial, right, so I4 basically, okay, share between two silicon diode, right, because in this circuit, okay, we have a parallel circuit, right, so we have two diode here. So basically for the I4 basically equal to I3 divided by 2. Okay, sebab dia split, the I3 di sini adalah I3, right, so dia akan split by 2, right. Kalau ada 3, dia akan split by 3 lah. Kalau ada 4, dia akan split by 4, right. So I3 divided by 2, then you will get 5 milli divided by 2, then you will get here 2.5 milliampere, right. Okay, okay, that's it. That's it, the tutorial, our tutorial today. Alright, so hopefully you guys able to understand, right, able to digest. Alright, so if let's say you do not understand, then please let me know, right. Okay, So okay, before we end this video, right? So I give you, okay, I will give you three homework, right, for this topic. Okay, so okay, you can do by your own. Okay, the question 1, question 2, and question 3. Okay, for the question 1, determine the value for I1, I2, and we not in the figure Q2A, right? So I also provide with the final answer, right? You can do by your own. Then lastly, you can check either your result, your final result is same or not, right? Okay, Q2. Okay, calculate the current IA, IB, and voltage output V naught. Okay, for the series parallel diode configuration as shown in figure Q2A, assume the turn on voltage for the silicon and germanium are 0.7 volt and 0.3 volt respectively. Right, so here I also provide with the final result. Okay, IA 2.5 milliampere, IB 7.46 milliampere, V naught equal to 1.89 volt. Alright. Okay, the last question. Okay, question 3. For the circuit shown in figure Q2A, illustrate a simplified circuit. Right. Then find the following value. Okay, current I1, I2, I3, and I4. Output voltage V naught and voltage at Vx. Alright, assume that VGE equal to 0.3 volt and VSI equal to 0.7 volt. Alright, so illustrate a simplified circuit. Okay, this one you need to draw the circuit, which is the simplified circuit. Alright. Okay, I think that's it. Good luck for this homework. Okay. Okay, thank you for watching. Assalamualaikum warahmatullahi taala wabarakatuh.